All right, guys, welcome back to Algebra 2. Today we're going to start talking about this worksheet right here, this packet. If you went to the drop-off on Monday, then you should have this. If you didn't go to the drop-off, if for some reason I missed your folder on the drop-off, whatever it may be, you can find an electronic copy of this directly below this post on your Google Classroom. So we're going to be getting into some basic statistics with this unit. It's kind of one of the last things in our Algebra 2 standards is to talk about some statistics. So that's what we're going to be getting into. Now, before we start the packet, I want to answer a question that I've gotten from a couple of you guys about this. And that really is, you know how the previous packet worked with it couldn't hurt your grade if you were unable to do it. It could only make your grade better. Your grade couldn't go down, right? I've heard from a couple of you asking, is that the same way with this packet and any future packets we get? And that is correct. No packet we get. This one, future packets, previous packets, none of them can make your grade go down. They can only make your grade go up. So that goes for all work during this period of time. So, let's go ahead and jump into this. So this covers the idea of the fundamental counting principle. You see that right here. It says if decision M can be made blank ways and decision N can be made blank ways, then the two decisions can be made blank ways. Well, that's not very descriptive without those blanks filled in, right? So here's what we want to do. We are going to use some variables in this sentence to describe what exactly this means, what exactly this is. So I'm going to write if decision M can be made X ways. So if there's X ways for something to happen, let's say, the oldest example in the book, you go to the lunchroom at school, and there are 4 different sides you can get, right? Let's say decision M is what side do you want with your meal? Then there are 4 different sides you could get. And then you have another decision N. Well, let's say that's what drink you want with your meal. And there will be Y decisions there. Some number, right? Some amount. Let's say 3. There are 4 different sides you could have and 3 different drinks you could have. Then we want to know how many different combinations of these can you have? How many different ways are there to pick a side and a drink? Well, what we do is we take the number of ways to choose the first decision and the number of ways to choose the second decision, and we multiply them. So any 2 decisions can be determined X times Y ways. So in the example we had before, if there are 4 different sides and 3 different drinks, we would multiply 4 times 3 and find out there are 12 different combinations of sides and drinks you can have. But in any given example, the number of ways you can make the first choice, the number of ways you can make the second choice, you multiply them. And if there's 3 or 4 or 5 choices, how many choices there are, you multiply each one. So let's look at an actual text example here with number 1. The ice cream shop offers a choice of 3 cone sizes, 15 flavors, and 8 toppings. How many cones are possible if you can only choose 1 flavor and 1 topping, right? So here's what we want to do. We want to figure out how many events there are. This is a term that I'm going to use a lot, is an event. An event is any time a decision can be made, or a choice can be made, or anything like that. An event is any time a decision can be made, or any time a choice can be made, anytime something can go in some combination of different ways, right? So in this example, there are 3 events, because you have to choose a cone size. That's your first event. Do you want, small, medium, or large, right? You have a second event when you have to choose one of the 15 flavors. And then you have a third event when you have to choose one of the 8 toppings. So in this example, there are 3 different events. And what happens under the fundamental counting principle is it says if you want to find out how many different ways something can go or how many different combinations of something are possible, then we are going to determine the number of outcomes for each event and multiply them. So the second term that I want to mention here is outcome. So an outcome is effectively the choice made in an event, right? The choices made in an event. So for example, again, if you are choosing the cone size, right? If that's your first event, what's the cone size? Small would be an outcome. Medium would be an outcome. Large would be an outcome. In other words, there are 3 different outcomes to the one event of choosing a cone size. How many outcomes are there when you're choosing a flavor? 15, because there's 15 different flavors. How many outcomes are there for toppings? 8. So what we're going to do is I'm going to line this up and say I have 3 events. So I need 3 numbers that are multiplying each other. 1 number for each event. Event 1, event 2, and event 3. All are going to multiply each other. How many outcomes are there for event 1? 3, because there's 3 different cone sizes. How many for 2? 15, because there's 15 different toppings. And how many for 3? 8, because there are 15 different flavors and 8 different toppings. So I would multiply all 3 of these. 3 times 15 times 8, and get that there are 360 different ways that I could make this ice cream cone. I'm going to go ahead and take a look at number 2 here. It says Virginia license plates consist of 3 letters followed by 4 digits. How many different license plates are possible? So here's what we got to think. We got to think about, again, how many events are there and how many outcomes does each one have? So if I take a look at this and I say, well, the license plate has how many total spots for a number or a letter? Well, if there's 3 letters followed by 4 digits, that means the license plate is going to have a total of 7, right? 7 spots for there to be a letter or a number. So each one of those spots is an event because that individual spot for a letter or a number can be chosen multiple different ways, right? So that's what we're going to do here. We have the first spot times the second spot times the third spot times the fourth spot times the fifth times the sixth times the seventh. So this license plate has all of these different spots on it that can go a multitude of different ways, right? So let's see what it says about each of these spots. It says it consists of 3 letters followed by 4 digits. So when I read that, what I take away from it is these first 3 spots are going to be a letter, and these last 4 spots are going to be a number. And when it says digit, you know, obviously it's going to be just a single number. It can't be like 12. It's got to be, 0 through 9. So we want to ask ourselves, if each of these has to be a letter, then how many different outcomes are there for that event? If we have to choose a letter for the first spot, how many different ways could we choose that? Well, how many letters are in the alphabet? 26, right? And again, we have to choose another letter. How many letters again? Well, there's still 26. It doesn't say that it can't be A, right? You could have the same letter repeating. You could have different letters. Each time you have 26 different options for what letter to choose. Then we have to choose a digit. Well, a single digit could be anywhere from 0 through 9. 0 through 9, well, there's 10 of those. So I have 10 options here, 10 options here, 10 here, and 10 here. Again, because at each of these spots, for there to be a letter or a number, I have a choice, right? A different number or letter that could go on this license plate. So I have to choose from the 26 letters for the first spot, from the 26 letters for the second spot, from the 26 letters for the third spot, and then from the 10 different single numbers for each of the next 4. So I will multiply these 7 events together. 26 times 26 times 26 times 10 times 10 times 10 times 10. And we get a massive number. That's what you're going to realize with some of these problems in this statistics packet, is some of these numbers are absolutely huge. Like, just looking at this, I don't know if that's in the millions, billions, trillions. I'd have to sit down and count those zeros. But it is a huge number. And then you got to think, well, is this number reasonable? You know, is this enough license plates for everyone in this state to be able to have a different one? Well, absolutely. There's only 330 million people in the United States, right? And this is just for, what, Virginia? So if Virginia has 175 million different license plate combinations, I don't think they're going to run out. All right, what you guys can do, try out number 3 and 4. We're going to go over these tomorrow in our video tomorrow. We'll go over them and just answer those questions, and then we'll get into stuff like factorials and all that. But try out number 3 and 4. See how it goes for you, and then we'll check in later. So if you have any questions on this, feel free to email me. Otherwise, I'll see you then.